All right, one more example. We've got a cookie serving tray. We're going to have a circular disc and then a rectangular cardboard divider in the beginning and the middle, sorry. Divider, total 48 square inches of cardboard. Right. Again, this is a numeric value that you're given, so this is going to be your constraint. Right. So this cardboard is the circle, pi r squared, plus length times width of the cardboard divider. And if you look at your diagram, right, your length is equal to the diameter. So in this case, I can use that the length is equal to 2r. So that gets rid of one variable. So now we have to get rid of, well, sorry, we're not getting rid of variables here. We get rid of variables on the optimized. So now let's check out what the optimized is. Right. Ultimately, we ask ourselves, what am I maximizing or minimizing? Right. Find the radius of the disk and the diameter and the divider's height. Right. In this case, this is height. Let's call it. Right. That will maximize the total volume of the cylindrical shape. Right. So volume is pi r squared h. Made by the full tray. Right. So that means I'm going to solve for h. Subtract the pi r 48 pi minus pi r squared. Okay, if I'm divide both sides by 2, this would be a 24 pi minus 1/2 pi r squared equals RH. And then if I divide by r, 24 pi minus 1/2 pi r squared all over r would be my h here. All right, so this now gets plugged in right here. So V equals pi r squared 24 pi minus 1/2 pi r squared all over r. All right, I'm going to just keep simplifying this. If I take this r and that r, I'm going to end up with pi r times 24 pi minus 1/2 pi r squared. Right, so now if I distribute this out, I'm going to get a 24 pi squared r minus 1/2 pi squared r cubed. All right, so this is now a function in terms of one variable. Limit height. Right. Again, that's the first thing I'm looking for. The next thing is we want to find a relevant domain. So use the constraint. Right. I'm going to set this equal to 0. 24 pi minus 1/2 pi r squared over r. So if I multiply both sides by r times 0 is still 0. All right, let's move this term to the other side. 24 pi equals 1/2 pi r squared. So I'm going to multiply both sides by 2. divide by pi. Right, so you get root 48 is your R value, which tells me that my relevant domain is 0 to root 48. Okay, so that's the second thing I'm looking for. Right, function in terms of one variable. Next thing we're looking for is a relevant domain. Third thing is to take the derivative. So 24 pi r would just be 24 pi r. (24 pi squared). Right, this is just a number multiplied by the variable. And again, this is just a number, so this is -3/2 pi squared times r squared. Right, you take this cube, multiply it down, decrease the power by 1. All right, so now we're going to set this equal to 0. All right, so let's move this over. 3/2 pi squared r squared equals 24 pi squared. All right, so first off, notice that both sides have this pi squared, so I'm going to divide that out. So you get 3/2 r squared equals 24. I'm going to multiply by 2, then divide by 3. Right, so that gives me that the radius of 4 is a critical point. Right, so now we're going to check. Right, the fact that we have an open interval means I can't use the EVT. What I can do is use either the first derivative test or the second derivative test. Right, I have a very clean first derivative right here. So I'm going to just use the second derivative test. Right, this is a constant, so that's 0. And this is going to be a negative 3 pi squared r. So if I put a positive 4n right there, I'm going to have let's see, negative 3 pi times 16, which is a negative number. So we have a concave up graph for the volume, and by the second derivative test, we definitely have a minimum function. Oops. And so now, sorry, try that again. We have a concave. Right. A negative means that we have a concave down graph, which ends up being a maximum. All right, so the fact that second derivative test gives me a maximum means that we have what we want. It says determine the radius of the disk and the divider height. So the radius is 4 centimeters, I think, inches. Then the height, if you look back at the very beginning, I'm going to plug in right there. So 24 pi minus 1/2 pi 16 over 4. And whatever that cleans up to be is going to be your height.